Hi, my name is Jonathan Green, a technology instructor, and today I'm going to teach you how to program video games using a program called Scratch. Don't worry, no prior programming experience needed. If you can solve a puzzle, you can code a video game. So what is Scratch? Scratch is a program that utilizes puzzle pieces to build code. This method of programming is called visual programming. It's made free, available by Massachusetts Institute of Technology. It's a web-based application, no downloads required, and you can access it from any computer in the world at scratch.mit.edu. Let's cover some basics first. We know that people communicate using language, or a series of words that are used to communicate ideas. There are many different languages spoken all around the world, over 6,500 total languages. But have you ever wondered how people communicate with computers? If you guessed languages, then you're correct. Specifically, languages used to communicate with computers are called programming languages, and there are over 9,000 of them in use today. Here is a simple list of some of the more popular programming languages used today. In its simplest form, a programming language is just a set of instructions that produces a certain output. And just like spoken languages like English and Spanish, there are parts to languages, such as verbs, adjectives, and nouns. Only in programming languages, we have different names for these parts. One of these parts is called an if statement. An if statement is a way to give instructions, and it's made up of two parts: a condition, if something happens, and an output or an outcome, then do something. We typically call them if statements or if-then statements because these are the two parts of the statement. So let's look at a real-life example. I'm sure you're all familiar with a red light and what to do at it. If we break up how to act at a stoplight into an if statement or a series of if statements, it would look like this. If the light is green, then your outcome is to go. Otherwise, else if the light is yellow, then your outcome is to slow down. And then finally, the third condition, else if the light is red, then you need to stop. And just like every language that's spoken has specific ways of saying things, so do programming languages. You need to tell the programming language that you're done with an if statement by putting the word end at the end of it. Okay, so now you understand the basics of if statements. Let's move on to how Scratch works. As I mentioned before, Scratch uses puzzle pieces to help you build code. But how does it look? So this is an if-then statement block. It is the most basic puzzle piece that we'll use today. It has a place for your condition here and your outcome here. So if we consider, again, the red light example, we place the outcome here and the condition here, we can simply read these instructions and they may make some sense. If there is a red light, then move. Only that would be really silly because at a red light, we're not supposed to move. Just checking to make sure you're paying attention. Okay, now we have a basic understanding of the knowledge that we need to build a video game in Scratch. Let's start. Pong is a simple game in which a ball is allowed to bounce off of 3 of the walls and the paddle. You control the paddle using your mouse, and as soon as the ball escapes either the three walls or the paddle and hits the red line, the game is over. And this is what we're going to program today. So let's get started. Once you go to once you visit scratch.mit.edu, create a login, and start a new project, your screen should look something like this. What you're looking at here is the code space. This is where we'll put all of our puzzle pieces to create code. To the left are all the possible puzzle pieces that you can use. The puzzle pieces are broken up by their function. So the light blue puzzle pieces will allow you to perform motion. Purple will help you modify the look and feel of a character. Lighter purple will give you modification for sounds. Yellow will allow you to modify events, and so on and so forth. When you're ready to code, you click and hold and drag onto the code space. If you realize you don't need a certain piece of code, you can delete it. Down here is an area for you to add characters using this button here. Characters are referred to as sprites in Scratch. Here is a preview area for your code. The green flag will allow you to run your code, and the red flag will allow you to stop it. These tools are very important. We will be using them a lot during this demonstration today in order to do something called debug, which we'll talk about a little bit later. And over here allows you to add a background, which are referred to as stages in Scratch. All right, well, let's add our first two sprites, one of which will be a ball and the other will be a paddle. So simply click on Choose Sprite, and you can select any ball you'd like. I'll choose this one and add another one and try and find a paddle. Okay, you'll notice now that I can click on the ball and the paddle and my code space actually changes. That's because the code that I write for the ball does not apply to the paddle. It's only for the ball. And the code I write for the paddle does not apply to the ball. It's only for the paddle. One more thing we'll do is we'll change our background. So click on Backdrops, select Backdrop 1, and then you can move to the Backdrop tab up here. This will allow you to edit your backdrop. If you'd like to choose from a preset backdrop, you can choose one of the many images. I'll choose Neon Tunnel. And now I'll go back to my Code tab. And now you see our preview window is showing what the app looks like so far. So I can click and drag and move my sprites around the background to get started. Okay, first we're going to program the initial gameplay. First thing that we want to do is we want to make the ball move. So let's click on the ball and let's start writing code. So the first set of instructions that we want to give the computer is that when the green flag is clicked, do something. Green flag means to start the program. The first thing we want the ball to do when the green flag is clicked is to start in the middle of the screen. So let's go to Motion, and let's grab the Go to XY puzzle piece. And we'll change these coordinates to 0 in the X and 0 in the Y. This will make the ball jump right to the middle of the screen. Let's give it a shot. So here I move the ball out of the middle of the screen, and I press the green flag to start my code, and you'll notice it moves right into the middle of the screen. I can move it again, start my code, and congratulations, you've written your very first program. But we're a ways away from a full-fledged game, so let's keep going. So whatever is placed underneath this first piece, when the green flag is checked, will happen only one time. We want to give the computer a set of instructions to repeat to make the ball constantly move. So we're going to add another block. This block is going to be called the forever block. Whatever is inside this block will happen forever until the program stops. So let's tell the ball to move a certain number of steps. Let's say 15 steps. Now let's debug. Let's run the program. What happens? Okay, the ball moves, and then the program ends. This is what we wanted it to do. So far, so good. But in actuality, we want the ball to bounce off of the wall. So we need to add another set of instructions. We need to say, if the ball is on the edge, then it should bounce after it's moved 15 steps. So let's try this again. Now the ball will bounce every time it hits a wall. Okay, we're getting a little closer, but not quite exactly what we want because we can't play yet. The ball is just following the same track every single time. So in order to fix this, we need to change the initial direction that the ball is pointing. And we only need to do this one time. So let's grab the block that says point in direction, and let's add it right underneath the start. Right now it's pointing in a 90-degree direction, which means it's going to move this way every time, which will result in the ball never reaching the paddle. So what if we change that to 45 degrees? What do you think will happen? Let's find out. There we go. That's better. Now the ball's bouncing off of all the walls. Excellent. Okay, so now the ball is doing what we want it to do. But the next part of the game is to be able to control the paddle, which we'll save for a later point. But first, how about we program the end of the game, when the ball hits the bottom of the screen. So we'll stop the current motion, and we will edit the backdrop to have a red line on the bottom to indicate the end of the game. So I'm going to change my color to red. I'm going to take the line tool, maybe make it a little bit thicker so it's easier to see. And I'm going to draw a line at the very bottom of the screen. And that's it. Now let's go back to code. Select the ball. Here's our ball code. And let's add an if statement. Very simply, what we want to say is, if the ball is touching the red line, then stop the game. So let's grab that if statement and we'll add it into the forever section of the code to repeat forever. And we need to add our condition here. If what? If the ball is touching red. So we'll go to our sensing puzzle pieces and we'll grab touching color. So remember, we're under ball. So we're saying if the ball is touching this color red, then do what? Stop the game. Stop the game is under control, and its instruction is called stop all. Okay, let's try it. You see, as soon as the ball hits the red area, the program is stopped. The code is doing exactly what we want it to do so far. But we still don't quite have a fully functioning game yet. What's missing? Well, how about the paddle? We can't control the paddle yet. So how about we write some code for the paddle? Let's click on the paddle, and you'll see our code space changes to a blank space. That's because we haven't written any code for the paddle yet. So we're going to start this block of code the same way we did the previous block. When the green flag is checked, what will we do? Well, we're going to have to set the location of the paddle to either a fixed location or a dynamic location according to our mouse. So how about we grab the motion puzzle pieces and let's set X to a fixed position. But do we want to set it to a fixed position? No, we want to set it to the location of our mouse. And you'll find the mouse location under Sensing. Mouse X. So just a quick note, the X-axis is this direction here, long ways. The Y-axis is up and down. So let's move the location of our mouse in the X into this set X to mouse X position. And let's try it. Uh-oh, it doesn't work. Why doesn't it work? Well, what we said and what we told the computer was when the green arrow is checked, perform this set of instruction one time. It's not continuously repeating that instruction. We didn't tell it to do it forever. So we need to put this in a forever loop. Let's try it now. Now, when I move my mouse, it moves the paddle. Excellent. So the next step is we should probably move the paddle down a little bit closer to the red line. And we don't want it to move with our mouse. We want it to be in a fixed Y location. So let's go back to motion. And just like we set X, let's set Y. And we can set this to negative 160, which is somewhere at the very bottom of the page. And now you see my paddle is much lower. Great. There's still one major problem. The ball doesn't bounce off the paddle. So how can we make that happen? Well, let's go back to our ball code. And I think that we're going to want to add another if statement. We said if the ball is touching the red, then the game is over. But how about we add another if statement saying if the ball touches the paddle, then something happens. So we'll grab another if statement, and we'll say under sensing, instead of touching color, we're going to say touching something. In this case, it's saying touching the mouse pointer. Instead of the mouse pointer, we can select the paddle. If it's touching the paddle, then what should it do? Under motion, there is a block that says to turn a certain number of degrees. And if we set this number of degrees to be 180, which is all the way back around, that's the same as saying bounce back. So let's try it. Look at that. The ball bounces right off the paddle. Excellent. And if I let the ball go, the game is over. Congratulations! You've programmed your first video game. Now there are many additions that you can add to this game. One of the additions you can add is sound. If you'd like to add sound, you can plug it in anywhere into the code here. So say we want to add sound for when the ball bounces off the paddle. Let's click on the Sound tab, and let's grab the block that says Start Sound Pop. Simple pop sound. You may not be able to hear on this video, but I'll try and turn the volume up. Now, we can plug this pop sound in to the part of the code after the ball bounces off the paddle, which will be right here. So if the ball touches the paddle, play this pop sound, and then make it bounce the other way. Let's see if we can hear it. Excellent. It works. If you'd also like to add a sound when the game is over or when the ball hits the red line, you can add another sound here and change the sound if you'd like. Let's try it. There you go. So congratulations, you are now officially video game programmers. Feel free to play around and add anything that you'd like to your game, or customize it in any way that you'd like. And get creative, maybe build something completely different. Thanks for watching the video, guys. Have a lot of fun.